Cool. Well, I'm so sorry I'm not able to be there in person. I love everyone in this room and especially this topic. It's very close to my heart, and also our research over the past, I don't know, 10 or so years. And I wanted to sort of start talking about some of the work we've done in the lab and also where we're headed on motivating energy conservation. So in terms of why people don't act, historically our work has looked at facts and feelings separately. So facts is it's sort of this idea of information deficit, that people don't know what they should be doing even though they might be motivated to act. And in the motivation deficit model is that maybe we need to change the social norms. We need to get people to pay more attention to issues. So we've been looking at these two things separately, and now with new research in our lab, we're trying to merge these two areas together by fusing facts and feelings. And I'll actually end our talk talking about this new research. So a lot of you are already familiar with the research we've done in our lab, looking at perceptions of energy use. So I'm just going to walk through this really quickly and talk about the new line of work that we're doing to correct these misperceptions. So over here on the y-axis, you have perceived energy used or saved in watt hours. On your x-axis, you have actual energy used or saved in watt hours. And when we start off, people have no idea what a watt hour is. So we say, all right, assume a 100-watt light bulb uses 100 units of energy. How many units of energy would your laptop use? Would your air conditioner use? And sort of in general, this is the slope of the curve. For example, on average, laptops are overestimated by a factor of 2. So people think it's equivalent to one light bulb when it's actually equivalent to half a light bulb. And now it's actually a lot less than that. Using your dishwasher is underestimated by a factor of 9. So people think it's equivalent to 2 light bulbs when it's actually equivalent to 18. And changing the washer setting from hot to cold is underestimated by a factor of 40. So people think it's equivalent to 1 light bulb when it's actually equivalent to 40 light bulbs. So we've sort of identified these severe misperceptions of how people think about energy, especially this compression bias that exists on the higher end of energy use. And so what the challenge is how do you take this really flat curve and pull it up towards the diagonal? And then the second question that arises from that is if you have people thinking more accurately about energy use, how does that affect real-world behaviors? So in order to start looking at this work, we've only collected 2 data points as yet, and here are some expert data. They're so accurate. You guys are so great at this. And so the question then is that, all right, we have experts that are really accurate, and I understand this is a sample size of 2. We're still collecting a lot of data. So what is the difference between expert and novices in the way they conceptualize how much energy different appliances use? So what we wanted to do is we wanted to design and test different interventions that would help novices correct their misperceptions. And what we've done so far is we've tested 2 separate interventions. One is providing multiple anchors. So in the first original study, we only provided the 100-watt light bulb as an anchor. So what would happen to the curve if we sort of allowed people to gear shift? When you think about small, like appliances that use very little amounts of energy, you can think about a phone charger, for example, that's at 5 units. Then you can gear shift to a 100-watt light bulb. Then you can gear shift to a 4,000 watt-hour clothes dryer. Would that actually pull up the curve? And the second intervention that we wanted to test is how can we, so experts use a lot of heuristics when they're trying to make decisions about what uses a lot of energy. So one that we sort of were able to distill from our first work is that large appliances that primarily heat and cool use a lot more energy than you think. So if we were to tell people this one heuristic, would that actually change their perceptions about how much energy different appliances use? So here is our data. So I'm going to just walk you through this. On the left-hand side is an actual pure replication of the Atari et al. 2010 data. And what you see in the middle graph is you see the slope getting steeper and steeper and steeper. So the baseline is just providing a 100-watt light bulb as an anchor. The heuristic is saying that large appliances that heat and cool use a lot more energy than you think. The anchors is the 3 anchors, and in black is actually providing both the heuristics and the anchors. And so what we show here is you're actually able to provide very small amounts of additional information to get people to become more accurate in how much energy they think different appliances use. And so from our perspective, this is the first time we've been able to see this. So we are able to make the slope steeper. What's really interesting, and this sort of tees in very well what Jonathan was talking about in relation to light bulb use, is that historically, when people are asked, in your opinion, what is the most effective thing you could do to conserve energy in your life, people think about the light bulb. So in our own work, 20% of our participants, and this is the modal response, say turn off the lights when they're asked about the most effective thing they can do. And this was data that was collected in 2009. And what's really interesting is that about what people think is effective. And he's also found, and this was in the 1980s, and he's also found that people think about turning off the lights as the single most effective action. So in this new work, what we're trying to do is, why is it that people think about turning off the lights all the time? And so this is a quote directly from the short list, which is a beautiful paper by Gardner and Stern. Behaviors that are easiest to remember and perform, for example, turning off the lights when leaving the room, tend to have minimal impact on climate change. So I'm not telling people not to do this, but it actually has a small impact compared to other actions. And so what we have over here is behaviors. So we've collected this brand new data, and this is a paper that's under review. We asked people, what is the most effective thing they could currently do? Followed by a second question is what they could be doing. And so over here you see how sticky turning off the lights really is. So 36.3% of our participants state turning off the lights, whereas only 7.8% state replacing incandescent light bulbs with CFLs or LEDs. And so this behavior, this sort of heuristic is really, really sticky. We actually also asked participants why they think this behavior is really sticky. And here are their responses. So we told people, all right, historically, we have this finding where people really think about turning off the lights. It's not as effective as people think, but why do you think people state this? So a lot of our participants said, it's a really easy behavior to do. They're taught this. It's a lack of knowledge, common behavior, everyone does it, so on and so forth. So using this information, we're actually trying to identify why are these behaviors that are so visible, that are so sort of common, why are they so sticky? What we actually also did was we looked at two separate behaviors, turning off the lights on the y-axis here and replacing incandescent light bulbs with more efficient lighting on the x-axis. And we asked people to rate each of these different attributes as to how strongly they agree or disagree with this particular attribute being tied to this particular behavior. And anything that's above the diagonal line is an attribute that is more common for turning off the lights. Anything that is below the diagonal line is an attribute that's more common for replacing your incandescent light bulb with a more efficient one. And so what you see here is things like being taught, it's a habit, you feel guilty if you don't do it, everyone does it, you're able to do it, it's easy. All of those really are much more salient for turning off the lights than they are for efficient lighting. So our big challenge next, I think, especially for this workshop, is that we need to make more effective behaviors salient, and we need to move beyond these feel-good but seemingly useless behaviors. And the second challenge, I think, and this is something our lab is doing, is we need to create a library of heuristics for conservation in order to test their effectiveness. So we've just looked at one heuristic. It might not be the most effective one. So there might be other heuristics out there that experts use. And that's new work that we're starting in our lab. And Joe Kattenbacker, who's in the audience right now, is leading on that effort. So with that, I'm hoping that there'll be time for some Q&A. And I'd like to end by talking just very, very briefly about a brand new project that we're starting in our lab, which is we're looking at how stories can motivate action on climate change. So we're actually asking people to imagine the future and how do they want to get to that sustainable future by thinking pathways of decarbonizing the energy system. And I'm happy to talk more about that either now or offline. Thank you so much for your attention.
So if there were any kind of short, kind of more technical questions about clarification, we can take those now, but then I'd like to kind of have all our speakers speak, and then we'll have a much more extended general discussion. So I think we'll move on to our next speaker. So, Leslie, would you like?
Sure.
Let's see, what do we need to do? There's, where do we have?
So it's that PowerPoint button at the bottom. Should have
Okay.
a lot of them open
Okay,
already.
great.
So
So,
Herman
there
is
we
right
go.
there.
I'm going to do a little test with the probe first. Okay, so thank you for having me here today. I'm Leslie Herman from E3 Innovate. We're a local home performance company here based in Nashville. And our goal is to help homeowners, architects, and builders create healthy, safe, energy efficient, and durable, sustainable buildings, homes, essentially. We work primarily in the residential sector and very, very, very little in commercial. Here's our team. And I wanted to bring some insight. I added this slide right at the last minute because a lot of people maybe assume that we're very compartmentalized, that we can do just HVAC, just insulation, just air sealing, just weatherization. But really what our company specializes in is taking a really broad perspective and integrating it, because we believe and we operate from the standpoint that the whole operates more efficiently than the sum of all of its parts. And that works across disciplines, and it also works in home performance. So when we take that perspective of looking at all the pieces and how they fit together, we're going to get a better result than if we just do HVAC or if we just do insulation. But communicating that to the rest of the public is very challenging. So it makes kind of a difficult business model. But we spend a lot of time educating our callers. Why do we do what we do? Why is it important to take that whole building approach? Because all of those pieces connect together to create a more efficient home. Great. So some of the challenges that we face, we find that people are reactive and not proactive. So people are making the home efficiency improvements or other improvements, not just for efficiency, but for things like indoor air quality. They're preventing mold. They're keeping the humidity in their house under control and staying comfortable and not sticky in the summer. Those are reactive decisions rather than proactive decisions. We also find that few individuals invest in energy efficiency because it's the right thing to do. Every so often we get callers who say, you know what, I want to build an efficient home because I believe it's the right thing to do. Those are few and far between, but we love it when they call because we know that they're already on board with our thinking process. And energy and water, the resources that we have at our fingertips every day, are still affordable for the majority of people out there. And so people aren't making, again, that decision based on how much is this going to cost me in the long run. It's how much is this going to cost me right now. And the paybacks are too long for people to invest in energy efficiency. So what is our approach? We have to make it personal. How do we make it personal? We get either to their pocketbook, right, energy efficiency, cost savings, or we get to their heart. How does it affect me? And what we're finding are that a lot of individuals are calling because of personal situations in their home where they're either not comfortable, hitting their heart, they're unhealthy in their home and they actually can't even live in it, it's getting to their heart, and they're ready to make a change just like that. I don't care how much it costs, let's get this implemented. The great news is that those same components that we use to create a more efficient home are the same as those we would use to create a healthier home and a more comfortable home. So kind of changing our approach. I love this picture because it really sums it up. Picture's worth 1,000 words. And what we see here is a decomposed possum next to a duct lying on the ground that's become disconnected from its register boot. Why did this client call? Well, maybe they were having hot and humid issues in their home. Maybe they were having an odor problem. But the thing is that energy efficiency and home health go together like pancakes and maple syrup. So I bring this slide up as well because we are familiar with the sick building syndrome from the 1970s, where we built buildings, commercial buildings typically, very tight because we were in an energy crisis. the result of that were sick buildings because we didn't get the other component right, the ventilation part. So people are having headaches, people are having drowsiness, brain fog, all of this stuff in a building. And it was a result of trying to save energy, doing the right thing for reasons, but not taking that whole perspective and looking at also ventilation and how to create an efficient and a healthy building. So this is the same case in our homes today. Homes are getting tighter and tighter and tighter for energy efficiency, but people aren't necessarily seeing the benefits of a tight home. Tight homes aren't being created with that holistic approach, so we're running into a lot of humidity issues that are causing mold and moisture, and it's not being done right, so we're not actually seeing the savings, the energy savings that we could if we took a step back and really looked at quality. We need an integrated approach. We need an interdisciplinary approach. We need to get more players involved. I use the idea of home health here because, one, it hits people in their heart. People are ready to take action right away. And the same components, again, like I mentioned, improve home health and efficiency at the same time. So I've included in here a doctor in this photo because from our perspective, we see that doctors can be advocates for energy efficiency in a way that is actually kind of masked. It's coming at it from a home health perspective, but what they're actually doing also, that they may not realize, is promoting energy efficiency. Because an efficient home is also a healthy home. If we think of LEED, for example, who's familiar with LEED? Great, a lot of people, awesome. What do we think of emotionally when we think of a LEED home? We think of a daylit space. We think of light air. We think of a clean, fresh smell. Those are all aspects that also relate to a healthy indoor environment. It's also an efficient home. One company, well, I guess more than just a company, a hospital, actually, this is a great example out of Kansas City, Missouri, has integrated a home performance department into their hospital. So every child who comes in with reoccurring asthma conditions gets flagged, and they send a home performance team out to the house. And they look for components of the home that would cause respiratory conditions, headaches, allergies, anything that's going to be involved in that patient's symptom category list. So this company, if you read down here at the bottom, this is a screenshot on my computer, they offer a course. The hospital offers a course for auditors and weatherization staff that talk about the overlap between home health and energy efficiency. Another idea that we're playing around with at E3 as well as with the Tennessee Environmental Council is this concept of a healthy home index. Who here has heard of a HERS score? A few people, great. A HERS score is an index that helps you compare your performance of a house to your neighbors, for example, or to another home that you're going to purchase. It's a scale from 0 to infinity. 100, the 100 mark, represents a house built to 2006 building code standards. So you're going to be somewhere typically, if it's a new construction project, between 100 and 0. 0 meaning it's a net zero energy consumer. So of course you're still consuming energy, but you have enough solar or renewable sources that you're offsetting your consumption. So on that scale, where do you land? Well, we'd like to create that same scale that focuses on home health components. So it's going to bring awareness to the issues that relate to where it hits them, in the heart. Personally, it's a very personal approach, whereas not maybe as many people have the urgency for an efficient home. Many people have an urgency for a very healthy home. I want to give an example of one of the callers that we had who called in with a symptom. They said, we had an HVAC tech over the other day. They were messing around with our ductwork in the attic. We thought we had some kind of air leakage problem going on. They were jostling around the ductwork. I think they maybe, jostled the coils a little bit. The next morning after they left, I woke up and I couldn't remember my name for 3 hours. And I think I have a mold problem in my house. So this is a serious effect that again, we haven't inspected the home yet, but if it is a problem with ductwork and they're pulling in nasty, cruddy crawl space air and water and moisture and mold. They have a problem with their health, and they also have a problem with energy efficiency. So the Healthy Home Index would be one way to wrap this together in a package that could be delivered through a real estate transaction. A home inspector could include more of the healthy home components. You look at some of these pictures, and of course, this is from a home inspection. They're saying you have a water problem, but they're not saying you have a health problem. You look at the far right photo there. That's a bathroom duct that terminates in the attic, so it's not being vented to the outdoors. We see this all the time, even in new construction, all the time. Here's a home that was purchased. It's an existing home, was purchased without any insulation, none. So we've got to address the existing residential homes, and our current idea is to create a healthy home index that would help bring awareness to and be used real estate transactions. Could be used in platforms like Zillow. It can also help renters. Renters understand that this home maybe is healthier than this home. Again, health having a more direct impact on an individual than perhaps energy efficiency, if they can afford it. We also met with a doctor, and this was a quote that he said, the need for a healthy habitat cannot be overemphasized. So I think these play together very, very well. That's it. So in conclusion, really quickly, these were just another 5 concepts that came to my head early this morning, so I wrote them down in a slide. Automation is going to be very helpful. We're talking thermostats. Don't even make a non-programmable thermostat. It's 2019. Why do they even exist? Don't even make them anymore. That goes to bullet number 2, fewer choices. We have so many choices out there. I love my shower head. I love having water rain down on me. But you know what? If I didn't have that choice, I wouldn't choose it, and I would choose the more water efficient model, right? If I didn't even have the choice to be watered down on. Higher utility costs, of course, that would hit the pocketbook, not so much the heart, maybe both. More awareness, of course, education, helping that healthy home index make an impact through real estate transactions, Zillow platforms, etc. And then the personal connection. We've got to get personal with this stuff, as we saw with the first presenter in the very first slide. Thank you very much.
Okay, Jack, would you like to?
Yeah. That slide gets a little bit ahead of my narrative, but that's all right. I'll bring you there. Okay. You may have seen in the slides that Jonathan and Mike showed that the big hitter in that 2009 study was the public getting a more fuel-efficient vehicle. And so how did we actually do in respect to that over the next 10 years? Well, the results are actually disappointing. That's no surprise to you, I'm sure. But I don't think despair is in order. I think the good news has just been delayed as opposed to eliminated, because the future of automotive mobility is evolving towards reaching the goal that was established in that paper, and we're moving there in that direction, as I'll talk about in a minute. But what we witnessed in the last decade was people choosing larger vehicles, higher horsepower vehicles, as opposed to the more efficient vehicles, and that's why we didn't reach our goals. A decade ago, cars, which are sedans and other small cars, constituted about 60% of the light-duty vehicles that were sold. Today, they only constitute about 30%. Instead, that other 70% is made up of SUVs, crossovers, and light trucks. So this is disappointing for those of us who wanted to see a reduced carbon footprint. But over that same time period, research has been going on in a different technology that we didn't even think about seriously back in those days. And my optimism in the face of what's happened is that we have launched the first serious challenge to the oil-based vehicles in over a century. And I am, of course, referring to the production of electric vehicles. Now, I recognize that electric vehicles are not going to overtake the existing market in a quick and easy fashion, but the trends are positive. Batteries are getting cheaper, our electric grids are getting cleaner, and so I want to talk about building upon those trends, what political systems are doing to encourage their development. But first, let's look at the statements of the automakers, majors in the industry, and you can see statements from the CEOs of Volkswagen, General Motors, and Ford, all talking about pushing towards a more electric future. And that picture came from a 2017 cover of The Economist, which talked about the demise of the internal combustion engine, which was a big change earlier in the decade. The Economist was making fun of electric vehicles. Well, in 2017, that kind of changed the narrative, and The Economist saw that, yeah, there's really something here. Now, it's understandable if you thought that this was, you know, a bunch of talk by the CEOs and a bunch of greenwashing, and we shouldn't take it seriously. But I think there are reasons to take it seriously, and I'll get into some of those right now. Let's see if I can operate this thing to get the next. There we go. One thing that's happened is that a number of countries have taken the initiative to put forth what we call phase-out declarations. And you can see the list of countries that have done that and the years in which they talk about phasing out internal combustion engines. And they're not talking about eliminating the remaining ones from the stock of but in other words, they'll eliminate the sales or the importation of internal combustion engine. And it's a pretty substantial group of countries in terms of overall global stock of vehicles. And then over there on the right, you can see that over 20 cities have signed on to a declaration that commits them to make major areas of their city free from oil-based vehicles. Now, these are declarations based well in the future, so they have no legal standing, but they do, I would submit, commit or begin to make a presumption that the future is going to be different than what we have today. And it's, as political scientists say, it's a form of political signaling of what's going to come next. And in doing so, they create an international norm which moves societies in this direction, even if it doesn't have the force of law. But let's talk about equally important, or maybe even more important than those declarations, are the regulatory paths that are moving the companies to electric vehicles. And I want to point out two governmental jurisdictions that haven't declared an end to internal combustion engines, but are moving their regulatory systems to produce that result in a more incremental fashion. And the most prominent example today is China. They have a new energy vehicles regulation. It's a credit-based system requiring automakers to sell the equivalent of 10% of electric vehicles in 2019. That's this year. And 12% in 2020. And they're going to make up their mind how fast they want to go after seeing the results of here. Now, that doesn't exactly translate into 10% of the vehicles because it's a complex regulatory system which you can get credits for in lieu of producing these things. But it does get the automakers to play that game, the regulatory game, and begin to introduce the vehicles. Volkswagen in particular, I think, if you looked at, they're probably the company that is most committed to an all-electric future. And I would dare say that it's because of China more than anything else. Volkswagen sells 4 out of its 10 vehicles. Every 10 vehicles that it sells, 4 of them are sold in China today. Most people don't realize that. And to ignore this kind of regulation would be irresponsible for Volkswagen to do that. So China has got its own reasons for going all electric, and it attracts anybody who wants to sell in China is going to have to play in that game. Now, China got this system of new energy vehicles from California. They came over to California and said, maybe we can learn from you because California's had its zero energy vehicles regulation for 30 years, I think. And it's only now beginning to have some bite to it. And so, again, if you want to sell in California, automakers are going to have to create a number of electric vehicles. Up to this time, they've been paying through this regulatory system to avoid that, which has been to the benefit of companies like Tesla. But it's ratcheting up that payments will not be sufficient to meet the regulatory requirements in the future. And then, of course, there's the European Union, which doesn't have the kind of system that California and China has, but it has produced a target for carbon emissions reduction by 2030, which people estimate that about 1/3 of those cars to meet that goal will have to be electric. So we've got a number of forces on the horizon that are moving to create this electric vehicle future. Now, it's still going to require that batteries get cheaper, and they've been decreasing by about 15% a year for the last few years, and I don't think we've reached the end of that possibility. But the general conventional wisdom that in 2030, about 25% of the new vehicles sold will be electric, plug-in electric. I think that's very conservative. I would expect that once parity with internal combustion engines is reached, that the switch over to electric vehicles will be rather fast rather than slow, simply because there's no reason why, if you get cost parity, there's no reason why you wouldn't prefer an electric vehicle for many reasons. So I'm optimistic that even if we didn't reach the goals that were set out in the 2009 paper in terms of fuel-efficient vehicles, we're moving in that direction just at a slower speed than we envisioned earlier. So that's all I have to say. Thank you.
Slides up.
I'm glad the previous speakers kind of set up the tone before my talk, so I'm going to cover a lot of behaviors here. So I'm going to talk about energy efficiency, energy justice, and then talking about now and the future. Future doesn't mean the future technology. It's already the technology we have now, but we haven't fully adopted yet. So So I'm going to talk about smart home management system, demand response, and time scheduling, our time related activity, how this related to our acceptance of demand response across income groups. And then electric vehicle, I'm going to talk about a study in Nordic country with multi-fast, different kind of factors, and talking about the cultural comparison between Japan and US residents. So this is kind of a little bit introduction of the framework of our energy justice research. We're looking at how much people can afford all these energy efficiency appliances and how accessible to the low-income household, and how much we actually adapt in terms of behaviors, energy practice, and in terms of resiliency, how this behavior change from peak hours to off-peak, how this related to power grid, and from human behavior perspective. And we look at micro level versus macro level, and we also look at our social psychological factor. This is a lot of information I'm going to go through quickly because I only have 10 minutes. So the basic framework is like social practice theory and then also Gideon structure theory. You know, a lot of behavior, we are constrained by the structure factors. For example, if you are low income, I'm going to demonstrate later. If you are low income status, you are renters, then it's difficult for you to change certain behaviors. So we use residential energy consumption data because this is a representative sample, and it examines a lot of behaviors such as space heating, cooling, lighting, Energy Star appliances, whether get assistance from the government in terms of the realization, audit, tax rebate. So it's a rich data set in terms of current energy practice and then also future energy efficiency adoption. And we look at about 7,000 households and divided by low income, medium income, and high income. We don't look at just income level, we divide it by household size as well. And so we look at the energy cost per square footage across 3 income levels. We found low-income households, for some reason, they pay more per square feet than other income groups. They also have low rate of the receiving assistance programs. So this could be the knowledge issue, could be it's difficult for them to process all these assistance programs. The application process, we don't know the reason, but it's pretty low in terms of percentage. Also, they have low rate of replacing a lot of energy efficiency program, as you know, you are not surprised because the cost or the rental status, so they cannot replace a lot of appliances. So they have lower percentage of free subsidized home energy audit, utility or energy supply rebate, and tax credit, recycling all appliances compared to other incomes. And we look at all the energy efficient appliances, including Energy Star appliances, central AC, heat pumps, and all this kind of programmable thermostat, AC thermostat, and add them up all together, we found, you know, again, low-income household has a lower adoption rate, and then also because they are renter status. So it's pretty not surprising, but also shocking how low, you know, compared to other income groups. Then we look at the energy practice, their behaviors, thermostat practice behaviors. 49% of American residents, they set one temperature and leave it there all the time. So that means that's efficient. So, you know, so that's, and I also set point, there's a differences across income groups. So if we look at space heating behaviors, thermostat control strategy, just looking at all kind of, regardless if they have thermostats or programmable thermostats, low-income household, they have higher percentage of setting one temperature and leave it all there. If we look at only programmable thermostats, low income still have higher percentage of setting one temperature and leave it there all the time. So this is a pretty big differences between low income, medium income, and high income in terms of the thermostat control strategy. And looking at the set point, the temperature setting point, space heating behaviors, low income set higher temperature during the winter time compared to other income groups. So this is require us to study a little bit more. It could be their household insulation levels, and it could be knowledge level. It could be just behavior. I think it's one of the biggest issues here. So if we look at the smart meter information, low-income household has lower percentage of installation of smart meter, and then also they have a little bit lower than about lower middle income. They are about the same, get access to the smart meter data. And how much they view the smart meter data, higher incomes household has higher percentage looking at the data. And smart thermostat, low-income household has very low percentage in terms of install the smart thermostats. So how does this going to relate to demand response program when we try to encourage people to move their behavior from peak hours to off-peak? Sometimes we kind of rely on this smart thermostat to sort of automatic control the temperature. And so we are looking at how whether financial incentive or other override options going to influence people's behaviors. So we sample about 1,500 people in California, Tennessee, Texas, Virginia to look at a little bit across different climate zones and see how much people are willing to accept several demand response programs, such as install automatic switcher in their AC, at home, and how much people are willing to respond to utility company when they need to adjust their behavior, adjust the AC degree temperature. And we offer $30 incentives or override, like you can change your mind. So we look at whether financial incentives more effective or not. But and then before I get into that, we also look at social psychological factors. And environmental concern actually one of the important factors to influence the attitudes toward whether they think this is a good thing or not. And there's a cost and comfort, need and trust in utility company also important to this theory of planning behavior. I won't go through the details here. So we look at the three different income groups. What are the social psychological factors most likely to influence their willingness to adjust thermostats temperature in summer raised like 3 degrees? So we found out that lower income groups, actually social norms, attitude, and perceived behavior control are more important to them. Whereas high income group, environmental concern is more important to higher income groups. And in the middle group income, energy saving habits more important. So there's a different characteristics here among low-income households, how we want to target different income groups in terms of changing their behaviors. So we look at the social psychological factors here. Then let me get back to the financial incentive and control options. A lot of people say, they will accept this program without any condition. They will do it anyway. And there are a big proportion of people, 300 people, they say they will not do it no matter what. No matter you give them money or override, they just would not do it. We found there's a significant number of people convert from $30 to override. So we get them $30 option, they say, okay, well, I will accept that. But if we get them override option, they change their mind again. So that indicates that some people still want the control of their life or thermostats and in general. So let's move to the scheduling. Every day we do certain activity at certain time. So this is going to relate to the energy consumption level. So we look at the American Time Use Survey. Again, this is a very representative sampling, more than 10,000 people. And we're looking at low income, medium income, and higher income, their scheduling. What do they do during certain time in a 24 hours period? And this is the scheduling, looking at low income, high income, and medium income. And it's not too surprising that low income household, they stay home more. And higher income people, they go to work. So they are, like during the day, they don't consume energy. But they consume more energy in the evening time. And the peak period of time in the morning, higher income level is a little bit earlier than the low-income household. We also notice low-income household watch a lot of TVs. You look at the blue line, they watch too much TV. So this is tell us a little bit indication about demand response, how low-income household, utility company probably don't pay attention to them because they think their potential are low in terms of saving energy. But we have a different perspective. We think they have more potential because the money they spend on utility has higher burden to their household income. And they can actually save more. But this is a multi-fast complicated factors because their rental status, their household installation, but we think they have more potential to save energy. All right, so smart home management system, looking at a little bit future. This is like a smart home devices that can automatically control your own household appliances. So we look at New York and Japan, and we see the differences I'm going to jump a little bit faster here. So we look at the two cultural comparisons, and then we found that New York residents, they want trust in your utility company. That's more important to New York residents. But in Tokyo, the resident doesn't think this is not salient to them. And we also found that a lot of people say they want to adopt the technology, but they don't want to pay for it. So there's even just $1, only like 10% of people are willing to pay just $1 a month. So there's a barrier there. People just don't want to pay for it. And social norms, again, is very important to both groups. I'm going to jump into electric vehicle. This is a study you probably know, Benjamin Sovaco. This is a study they conduct in Europe and 5 countries, Nordic country. It's a rich data set, and I think they have published several articles there. I helped them to analyze this social, behavior, economics, technical factors, put them all together, and to do a hierarchical regression modeling. And so it's not surprising higher income people are more likely to adopt electric vehicle. Younger people, surprising more children, households are more likely to adopt electric vehicle. The environmental values, sustainability values, eating less meat, changing their solar renewable energy adoption are all significant related to electric vehicle adoptions. And we also find the carryover effect from traditional vehicles characteristics such as technology, reliability, fuel economy, cost efficiency, that transfer to their electric vehicle adoptions. We also look at the vehicle to grid and capability, whether this is important to the EV adopters, and this is a significant. And I'm going to build a real test bed because this is just an attitude, but we are going in Tennessee, we are going to build a real test bed on vehicle to grid a solar panel and then incorporate with social behavior. So this is I'm going to build more social and technological integration in addition to just attitudes. So in So let me conclude this study is there's some more behavior we can dig into, especially in Tennessee. Tennessee is going to claim, we are going to build this Drive Tennessee initiatives, and it's going to, hopefully will build this 1,000 liter of the electric vehicle. So this is something I think Tennessee is trying to do right now. So that's why I'm interested in this electric vehicle study. All right, thank you. And I'm going to thank NSF and DOE's support, and then also my postdoc, Xiaojin Xu. She had done tremendous work on the odor analysis. Thank you.
Okay, so I'm going to present just a little bit about some of the issues around assessing the technical potential to then tie into a lot of these discussions about what does it take to realize that. And then we'll open things up for discussion. So let me see. Oh, yeah, there it is. Okay, great. Okay, so just want to talk about some of what I'm working on with updating the assessments of technical potential from our paper 10 years ago. And the context here for this, what I'm going to present here is going to focus for simplicity on detached single-family homes, because these are both the dominant housing for people in the U.S., and also we anticipate if people are living in a detached single-family home, then the resident has the highest opportunity to be actually implementing a lot of the weatherization, upgrading HVAC equipment, et cetera. And so kind of a little more detail on energy-efficient lighting, kind of building on what we were talking about with Mike and some things that Shazine raised. Compact fluorescent light bulbs reduce emissions about 75% over incandescents, and they save about $160 per light bulb over 20 years. So there's no reason economically not to just install them. LEDs are even better. They reduce emissions more, they save more, and they even reduce emissions about 45% over compact fluorescent light bulbs, and the savings in dollars is negligible. It's $1 a year per bulb, but it's like, why not? And LED bulbs are now down. As of recently, you can even get them for less than $1 in a lot of places. So there's no reason why people shouldn't be replacing incandescents or even CFLs with LEDs. Most homes have at least one energy-efficient light bulb, but about half of the homes, about 35 million homes, have mostly incandescent bulbs. This means that there's potential for reducing emissions. There's about 46 million metric tons of CO2 per year from household lighting in just the single-family detached home sector, according to REC's 2015. So if the households who have mostly incandescent bulbs switch over to mostly LED, we could have big financial savings to the households and big emissions reductions, about 25 to 30 million metric tons. About 30 million metric tons per year is potential, and that's on top of then the 25 to 30 million metric tons per year emissions reductions that have already been achieved by the rapid adoption of CFLs since 2005. In terms of space heating, things are not moving along as well. There's not been a lot of progress since 2009. This is comparing 3 different editions of the Residential Energy Consumption Survey, and we're seeing that basically over time, people are not replacing their furnaces. The furnaces are getting slightly older on average, with more than half of people having a furnace that's more than 10 years old, and so would potentially be suitable for replacement with an energy-efficient model. The energy efficiency standards, on the other hand, have gone up. So the technology is improving, but the behavioral choice to adopt it is not showing up. Similarly, we're not seeing, from 2005 to the present, any significant reduction in the number of homes that are inadequately insulated or that are drafty during the winter. And so simply looking at just one technology, gas furnaces, there's the potential now for 12 million metric tons of carbon dioxide emission reductions per year if all of the gas furnaces over 10 years were replaced with Energy Star models. That's more emission reduction than the 2009 paper estimated as the technical potential for all improvements of HVAC equipment. So because of technological improvements, the technical potential has gone way up, but we don't have the initiatives and we haven't been taking advantage of the behavioral plasticity. And this is important because when appropriate programs are put in place, the empirical data from the energy efficiency work in the 1970s, the stuff that Paul pioneered, says you could have really high behavioral plasticity if you have an effective program in place. So this is a place where we're simply leaving opportunities on the table. The challenges here are, this is all based on engineering estimates. There's recent work by economists that are finding that at least in some places with large data set, that people are not actually achieving the predicted savings from weatherizing their homes. And this is enough to turn it, basically people are achieving in this study in Michigan only 1/3 of the predicted savings, and that turns this from being a net cost saving to a net money losing proposition to weatherize the home. That's from the Weatherization Assistance Program, but other programs like the PACE program put in place Long Island Green Homes that's been around since around 2008 or so, finds from their audits that they're actually producing net cost savings, so they're able to continue to finance people weatherizing their homes, doing energy upgrades, and paying it off out of the savings. And so this is suggesting that we need to not just blindly say everybody weatherize your home, but have good energy audits to start with, and then focus on the places that have the highest cost-saving potential and the highest emissions reduction potential if we want to do this effectively. So we have to be thinking about putting assessment and prioritization in place if we want to be realizing the potential savings. And then this brings me to simply looking at the distribution of heating emissions. So this is basically plotting a standard Lorentz curve and finds that there is a reasonably high Gini coefficient. So 20% of homes are responsible for 40% of heating emissions. Some of this is just climatic. Not everybody lives in cold places. But it also has to do with the characteristics of the home. In air conditioning, it's even more extreme. 10% of the homes produce 35% of the air conditioning emissions, and 20% of the homes give more than half of that. So if we think again about identifying and prioritizing the big emitters and the big opportunities for reducing emissions, then we would potentially have the best shot at achieving some of the technical potential that we estimate. And so that brings me to the end of just giving a little bit of an overview of how we're approaching updating our technical potential assessments. And I'd like to open things up right now to just general discussion and questions from the audience and among the panelists. So thanks everybody for the great presentations, and we'll take questions from the audience. Anyone want to start? Mike.
So I'm sorry, I probably should be barred just because I was up there just a moment ago, but I have two questions that I think trigger maybe some of the further discussion here. And one goes to Jack on the question of how much technical potential is actually out there for electric vehicles. I think some of the work we're going to hear about from John Dernbach at the end of the day today and Mike Gerard from Columbia tomorrow looks at the Deep Decarbonization Project and suggests that one of the key forks in the road that has to be achieved is electrification of the motor vehicle fleet plus decarbonization of the grid at the same time. And this maybe goes more to initiative feasibility or possibly even behavioral plasticity issues, but what I'm hearing is that one of the barriers to uptake is not price, but is who benefits from the shift to electric cars and who is hurt. And the party that's hurt are car dealers, because they don't make money from selling cars, they make money from repairing cars, and electric cars don't break down. So that there is real resistance at one piece in the important chain of the uptake of electric vehicles that we might otherwise miss. And I'm just curious about whether there are initiatives or research or something that we could get at that might anticipate that barrier to the uptake of electric vehicles that we might not otherwise be thinking about. And a really quick version of that goes to Leslie, which is, we've been talking for several decades about programmable thermostats, and you suggested we should ban non-ones. I just bought an incredibly fuel-efficient heating and cooling unit, and I'm not getting any savings because it came with a programmable thermostat that I can't figure out. And I have a half-an-inch thick book, and so I'm worried that if we dictate programmable thermostats, we'll go backwards. And to the engineers in the room, why in the world don't we include behavioral scientists sitting down with engineers and then product managers when they deploy products so that the device can actually be used in a way, if I have to program my thermostat, I'd rather throw it out and use an old-fashioned one. I think I'd get better efficiency. And I think the research suggests most people don't deploy them in ways that work. So I'm curious about what all this means about what more research we need to do, what kind of initiatives we can adopt. Where do we go from here?
You're quite right in identifying dealers as sort of an impediment at this stage to the sale of electric vehicles. There's endless stories about how people will go into a dealership and ask to see an electric car, and they'll be shunted to other cars that the dealers want to make without adequate explanation of their initial request. And the dealers, it's not only a matter of they make more money on the sales of some vehicles, but it's also they tend not to be as educated as they should be on electric vehicles. So that isn't, I recognize it's an impediment, and there have been talks about educating dealers more, but, you know, that's a long haul, and so I don't really know what the answer is for that. Tesla's got its own answer, and that is avoid the dealership altogether. And if we see new alignments in the automotive industry, they may go down the Tesla route so that you avoid the existing dealership altogether. But I see it as a impediment, but not one that's a showstopper. So I think it's a matter of time before that's overcome.
Jinfei, do you want to talk about the Sovacool study?
Yes. I actually have an electric vehicle, so I can talk about that of behavior side. I think one of the biggest challenges is anxiety of this range. People think they will run out of battery, but actually, according to the study, people drive less than, I mean, I'm not talking about like commuting 1 hour every day. I'm talking about like in the city, you go to work, actually people drive less than what they expected. So this range anxiety should, you know, change people's mind. And also this battery actually is getting better and better. Now Tesla has, you know, 300 miles, but of course, not everybody can, you know, afford Tesla. But in terms of Mike's questions, Tesla style is more attractive than just the design, the speed, the design, and other things will attract more a different kind of group of drivers. So there's other factors we can tackle in, and then also Sovacool study also find that dealer is one of the biggest barriers, and so that's something we need to educate dealership, and then also educate general populations like electric vehicle. Yes, a little bit inconvenient, but not that much if you adopt it. It's just building your life, like you carry your bag to go to grocery store, and you just a little bit change your lifestyle a little bit. Actually, you can adopt the electric vehicle.
Yeah, if I could jump in on that on the electric vehicle and then turn over to Leslie, is kind of a couple of things specifically out of that Sovacool study with the mystery shoppers is they found that a large number of dealers in Europe are either very actively dismissive or even deceptive. And so there were examples of the dealer dramatically understating the range that the car could get and telling somebody, for instance, instead of adding like an hour or two to a long trip, saying that it would add 2 or 3 days to the trip to do it in an electric vehicle. And the study found that when dealers provided accurate information and were not actively disparaging the electric cars, people were much more likely to buy one. And on the range anxiety, as you say, quantitative studies are finding that it's like less than 1% of people take a trip in a year in, not necessarily everywhere, but in a number of cities they've studied, less than 1% of the people take a trip in a year that would be outside the range of a typical electric car. So the range anxiety is dropping, and in part of that, Tesla found they did a pilot study to say, oh, people with range anxiety who don't want to have to stop and charge their car, they instituted a program on the San Francisco to Los Angeles route where Tesla owners could pull into a Tesla-operated service station and get a 90-second, they would swap the battery pack out. Out of 200 people they enrolled in the study, 5 took advantage of the program, and 4 of the 5 only did it once and never repeated. So Tesla dropped the quick battery swap program because they said, you know, range anxiety, once people get used to the car, is not such a thing. And if you have fast chargers, people actually like to stop along the way, grab a cup of coffee, have lunch, and by that point they're ready to finish the trip to Los Angeles. So a lot of progress is being made in acceptance and so forth. And finally, we're at the point now where a number of studies are finding the total cost of ownership over the lifetime of an electric vehicle is thousands of dollars less than owning a gasoline vehicle. The problem is that upfront cost, which Jack alluded to, where with the progress on batteries, Bloomberg New Energy Finance, their latest estimates are you'll have cost parity around 2026 or thereabouts. So we are potentially on the cusp of that big transformation that Jack was alluding to.
Very good. Back to thermostats. We see this problem all of the time. We have high-end clients who have learning thermostats, like a Nest, for example, who don't know how to program them correctly. So we've installed them, set them up, and they've gone in and tried to change them and mess it up in the process, and we've had to go back and fix it for them, and they have multiple thermostats throughout their house, and they're not communicating with each other like they should. It's a huge problem. Another example is in Habitat for Humanity, simple, basic thermostat, not even programmable, but in the heating season, the thermostat was somehow accidentally set to auxiliary mode and ran electric heating coils the entire winter rather than in its efficient heat pump stage. So, and we caught that just through monitoring the home, and we saw this huge electrical load, and we thought, why is that happening? Thermostat. So one of our huge recommendations to Habitat was you can't leave this house until you teach the homeowners about every piece of their equipment with a how-to guide. And interestingly enough, I was a judge for the Race to Zero competition sponsored by DOE at NREL last year, and the winning group in my team, which was multifamily housing, was a group that incorporated a learning manual into the design of their home. So every home came with a learning manual, short pictures, designs of color-coded arrows, and this is how you do it. That was presented to their Habitat clients, and we thought that was a genius idea because we have to teach and not leave that house before the person is familiar with their equipment, and that goes back also to the installer. The installer has to know how to operate the equipment. And I think on terms of the design of the thermostat, it can be much simpler. Actually, it can come with pre-settings for thermostat setbacks. If you want, how about this? And it can recommend a thermostat setback for you. People say, oh yeah, okay, well that's preset. I'll just click the button and it's done. So we do need to work with designers, people from industry, people from homeowners themselves. We can all get together and think tank this out a little better before we sell products that don't do what they should.
So I'll pass the microphone around. As I'm doing that, I'm going to take this chance just to say, as a former policymaker, the idea of teaching 100 million households how to use their thermostat through intensive programs is a non-starter, right? And so I hope that when we talk about behavioral plasticity and initiative feasibility, we'll think in all these areas, not just about what we could do if we had unlimited resources, but what's realistic, viably to do. And it seems like your latter strategy or a home meter might be more easy to implement. Paul, were you?
For people streaming, this is Paul Stern speaking. I continue to have some of this Rip Van Winkle experience that Mike referred to earlier. First, I want to say that Leslie's company has hit on a really interesting and innovative approach by linking energy efficiency to health problems that people are experiencing in their homes. I mean, it's probably a relatively small proportion of the population, but a very strong motivator.
It's a huge, actually, section of the population, I would say, especially in this climate region.
At any rate, I want to flag that. But it's also the case that back in the 2009 paper, and to some degree even in earlier work, and in the papers immediately subsequent to that paper, we identified a number of design principles for intervention that are probably some of them more often neglected than followed in a lot of these interventions. And, among those are the principle of minimizing effort to adopt whatever technology it is that you want adopted, providing valid information from credible sources at the time of decision. And also, in the case of new technologies, targeting your marketing to early innovators. And your diffusion of innovation theory turned out to be very useful in a study that we did in adopting photovoltaics at the household level. That there were subpopulations who fit the profile of early adopters from diffusion of innovation theory that probably are important for EVs, but I haven't seen any research on that. Just some comments. Pass this on to, if anybody wants to respond from the panel, please do.
I always think it's important to know who your target audience is in anything that you do as a service or a product, right? That's the number one thing any good marketing teacher will tell you is you have to understand your target audience. And because we at E3 are so passionate about conserving energy and conserving our natural resources, that we've had to kind of bend and shift to target maybe a different audience that wouldn't have initially wanted or seen an urgency to adopt energy efficiency, but have now adopted a more urgent approach to other aspects of their home. So I think the early adopters for us are those who are almost, I want to say, awake or tuned in, who are sensitive and alert to what's going on in their immediate surrounding. And that's kind of vague, but it's a different perspective, I think, than just looking at energy efficiency by itself.
Mm-hmm.
I have a question.
Paul, let me just, the diffusion of innovation on EVs. There's a lot of speculation on entrepreneurs' part, how you enter that market. The Tesla model is you start selling a very expensive car, you make some profit, and then you go down the price change to get the more of the population that's beyond the early pioneer stage. There's another model that says you aim for the lowest cost possible, and then you get the largest uptake. And the EV industry has been remarkably unsuccessful in that. And what I'm hoping is that eventually we'll get some cheap imports from China that'll address that larger market out there. And all they have to do is look back at the experience of Volkswagen in the 1960s. They came in with a cheaper model that was good enough. And So I think there's a big opportunity for a Chinese firm to come in and approach the strategy of diffusion that way.
Yeah. I'd like to follow up on that, Jack, for just a minute. I think there's, first of all, one of the genius things about the approach that Tesla took is that by going for the high-end, expensive sports car, it makes an EV an aspirational thing rather than a hair shirt that you wear to show people that you're environmentally correct. And I think that really flips the way people think about it in an important way. On the inexpensive side, something that's very interesting is because you only get the tax break when you buy the EV new, and because the technology is improving so quickly, it's kind of like if you know what the market for your 2-year-old cell phone is, that's kind of what the market for a 2-year-old EV is. And there's an incredible, you can get a really good deal buying an EV that's a few years old. And I think that the used car market may become an important part of the penetration to selling to people who don't have a lot of money.
Okay, quick question. This is probably for Jack Barkenbus. What is the truth about vapor carburetors? And
Truth about what?
vapor carburetors, technology that apparently was invented a century ago that would take a typical vehicle, gas-powered vehicle, across country on one tank of gas. That sort of concept. Do those exist? Where are they? Will they ever come to pass? And the other question is, and I'll be quiet. The other question is there a role in the hybrid electric gas engines in the big picture here?
Your first technology is actually one I haven't heard of, so I don't think it's very prominent or would have come to my attention. I'm not an engineer, but so I can't help you with that. Your second question, Jeff, was, remind me again.
What is the role of the hybrid gasoline?
Oh, the hybrid gasoline. Right now, in jurisdictions across the world, some countries sell a prominence of pure battery, and some countries do the other. It's in terms of sales overall, it's about 50-50 now, hybrids and pure battery. Everyone feels that the hybrid stage is a transition stage, and I think that's true, that we'll go to full batteries as we see this progression of technological progress. But it's not an unreasonable stage to go through, and so there's still a lot of hybrids out there. They just don't get a lot of mileage on the pure battery side.
Yeah. I would add on the hybrid side, from the engineering point of view, you're basically putting a lot of duplicated technology into the car, so the wear and tear issues are real, much higher cost of maintenance than the battery-operated vehicles, and all the cost of producing it. So we're quickly moving into where simply cost of ownership is lower for a battery vehicle than for a hybrid.
So I want to go back to the problem of the low-income folks, because I think that's really a key one, and it goes both on electric vehicles, but I think demonstrated here the bigger potential with homes. And we did a study in 2008 of just the energy and how, so it was energy subsidies by the federal government. So one of the programs that's very important is the program for assistance for low-income people. And it is very difficult for low-income people to become eligible for it. It's a lot of work.
A lot of paperwork.
And it's administered by the state, so it's very uneven in terms of how much help they get in getting into the assistance program. So I think, I think there's a lot of work and thinking that needs to be done on the policy side of what do we do to make those changes. And one of the clear issues, which I think has been alluded to, is where are the incentives? There's no incentive, or very little incentive, on the homeowner or the apartment owner or whoever it is. And small apartments seem to be a fairly large, housing option, and very difficult for the renters to get to. So, I mean, that's a place where would like to see a lot more thought going into the policies and how we can deal with that.
I think this issue obviously is very complex, and so the first thing I would think that low-income households don't know how much they can save, the potentials. And then second thing is this barrier of going online and search information. That doesn't fly to a lot of low incomes who doesn't even Google or use a lot of search information, or they don't even know about the program. So that, in that sense, it's because I do know a few low-income households, they don't know something could be free. They don't know, oh, I can go to a free concert. They think everything they go has to pay. So I guess it's like more small community-built programs, like face-to-face interactions, probably would be more effective. Yes, internet information, yes, we need to put it out there. But the thing is, using more peer-to-peer approach, their community, that could be one of the incentive. And then the renter status is very difficult because they cannot do something about it. So they can tell their landlord. However, this is even more complex. Low-income renter status, that is super complicated issue. So that we cannot solve right away. But I think individual homeowner, they are low incomes. I think we need to target special groups and then just go in and talk to them, or use more peer-to-peer if their friends know that, oh, they can save $200 a month, or how much money they can save, and help them go through this process. It would be probably more useful. But yes, it's difficult.
If I can follow up on that, there was a very interesting, innovative program. It was only a small pilot, and they didn't decide to continue. They didn't have money to continue it. But City of Knoxville, in partnership with TVA, put a program in place about 2 years ago where they went in and provided home energy upgrades for single-family homes with low-income people. That could be owner-occupied or Section 8 rentals if the landlord agreed to keep it on the Section 8 program for several years afterwards. They sent people around door to door, as you suggest, to make people aware, and they tracked health outcomes as well as cost savings relating to what Leslie's been saying, and they found very significant health outcomes related to the cost of energy. So first of all, there were a lot of people who had to choose between paying the utility bill and filling prescriptions. So after the program, prescription compliance went way up, and also number of just nights when people didn't get an adequate amount of sleep, in part because they were trying to save money by not heating or air conditioning adequately. And so connecting the cost savings to state medical assistance programs to this may be an important way to start thinking about the policy, because you have very tight connections in low-income households between health and energy.
And I'm going to jump into that to electric vehicle. Again, there are lower costs of electric vehicle, like Nissan Leaf used. It's $10,000. It's very efficient, and so that's not a problem. But people don't wear it. They just think, oh, Tesla, so expensive, I can't afford it. But they don't know there are other options. So provide different kind of option could be very useful.
Yeah, latest CarMax prices on kind of couple-year-old Nissan Leaf is down below $9,000 now.
Yeah.
Yeah, I just had a couple quick points on the EV. I don't think we know what that economic model is yet, or it seems like it's still in flux. And so the Nissan Leaf's a really good example. They've got an air-cooled battery pack that the degradation on that pack over a 5-year period of time is very significant. So you might start off with a range of, say, 150, 175 or something like that. In 5 years, you might be below 90. And that's what the preliminary studies show. So when you're looking at comparisons between upfront cost of Tesla, which is liquid cooled, and some of those other competitors, the Nissan Leaf, and I think it's important to look at the entire life cycle of the vehicle. I guess the second point on that is we've got a 2013 vehicle that we get over-the-air updates on, and so that the technology in that vehicle from the software component is new. It's new this year. The UI interface, the software energy management has improved over the life cycle of that vehicle. And so what that means is, back to Jonathan's point earlier, the replacement value, or the residual value, rather, of that vehicle as you go through time is very, very different. And that, I think, is impactful for different automakers as they're approaching their different economic models. So Nissan Leaf has got a life cycle that would be much shorter than some of the other manufacturers that have a different approach.
Good point.
I have a question that sort of takes us out of the framework of sort of individual households or individual vehicles. So far, we've been talking about, individual household efficiency and also, individual vehicle efficiency. But what about thinking, how do we integrate this into a broader thinking about the overall system? For instance, multifamily houses and the choice of residency can also be either more efficient or less efficient. And the same thing about choice of vehicles. I'm struck walking around Nashville by how many electric scooters there are, which is arguably way more efficient, right, than electric vehicles. And so I don't have a good answer for this. I'm trying to think about this from the food system perspective. And, there's efficiency savings in the food production process, but there's also efficiency saving in consumer choice of, say, more plant-based foods versus less plant-based foods. So I'm wondering if you have any thoughts on this. I know it's a very broad question.
I think it simply goes back to city planning, and city planning in a way that integrates walkable communities. I mean, you look at the United States city planning compared to European cities, and it's dramatically different. I mean, you want to be walking around in European cities. So how do we take what we have now that's existing and kind of fill in the gaps? And I'm a huge proponent for infill rather than urban sprawl, and revitalizing some of these maybe less populated areas and just fill them in rather than sprawling out. But let's do it in a way that creates an environment that people want to live in. I mean, walkable communities with markets on each corner, and you live upstairs and you work 5 miles or less that you could bike to work on a nice, safe commute where your streets are smaller and your bike paths are larger. It's really just planning. I mean, there's nothing holding us back that I see, rather than bringing more people on board with that vision of greener communities.
So I think the EV charging station could be a community engagement place. I actually recently went to Whole Foods to charge, and people start talking to me, and I thought, oh, they are just interested in EV. I did not realize there's an association in Nashville, and they gather together every Saturday, every month, and talk about efficiency. They are just EV users. And they become a association, and then gathering Whole Foods. Now I'm going to invite them to my center and talk about this energy efficiency from the community perspective, because people were charging in Whole Foods. So Whole Foods is pretty smart. They have an internet, they have a charging station, expensive grocery, and so you go there, you have a task. You can do everything there. So that's a business model, kind of bring community together. So I think I see this in the future that we can build a nice supercharging station in the community, and then people can talk about this energy efficiency behavior and go beyond just EV vehicle, that kind of things.
Yeah, maybe if we're going to need to go ahead and wrap up shortly, but let me just, perhaps if I can, do two things. One, ask if Shazine has anything more to add, since I think she's still online. And then maybe we can wrap up with Jonathan just giving us a sense. I guess what we're hoping to get out of the panel overall, and I think we've gotten a lot of this, is how big is the remaining technical potential in the household sector? Is this a sector that we should still continue to focus on? Should it be a part if we do a private sector wedge? Should it be one of those subsectors of a private sector wedge initiative? What's sort of the bottom line in terms of the opportunity that's out there, not so much from a behavioral change side as much as just if we were to change that behavior, how much we would get from it? And maybe, Shazine, are you still on?
She is not.
She's not. Okay, no problem. No problem. No, that's fine. I just wanted to make sure if she were, that she wasn't just sitting there. Jonathan?
I sent her a quick message, so she may call in, but I gave her that option.
Yeah. Okay, so I think basically technical potential is looking better than ever. Technical potential, as I'm starting to look at updating it, is really up. The emergence of highly efficient light bulbs, emergence of new appliance technology, things we haven't talked about here, but heat pump water heaters, which we left off of our behavioral wedge paper in 2009 because they were like a custom thing. It was a huge hassle to get them. Now you can buy them in Lowe's and Home Depot. The electric vehicles are potentially going to revolutionize how we think about technical potential. So the technical potential is really there, and also the technical potential, the role of technology in unlocking behavioral things. As Leslie talked about the role of automation, and Paul has been emphasizing for longer than I've been aware of this and engaged with this. Paul's been emphasizing how much convenience, making things easy for people is really important in engaging on the behavioral side. And the role of technology and automation has huge potential, but as we've discussed around programmable thermostats, it ain't there yet. And that's an area where I think on the technological side, engineers will have a lot to contribute going forward in connecting the technical potential of simply energy efficiency and shifting away from fossil fuels to using technology to make that shift easier, more convenient, and less disruptive for our lives. But I think the key is going to be all the technical potential in the world isn't going to do us any good if the people on the behavioral side are not able to help get the technology adopted. And that's why these kind of interdisciplinary conversations are so essential.
Great. Well, let's thank Jonathan and the panelists for their great program here. I have the happy news letting you know we're heading to a break here, and then we're going to reconvene in about 15 minutes at around 10:45.